MacMaths, MacMaths, let's do some maths today. Ta-da. So this is just support with exercise 9D. I'm just going to go through some questions. I'm going to go through every three. I'm going to go 3, 6, 9, 12, and I'm not going to do 15, which is the last one, because 14 is much harder. So I'm going to go through 14. So these three, 12 and 14. So let's start. I've simplified the question down. A cyclist is travelling at 12 meters per second originally, decelerates to rest, in other words, to 0 over 36 meters. Find the deceleration. Okay, so always draw yourself a diagram. So here we go. And on this diagram, this to rest, you're going to come across this especially when we're throwing stones up in the air. There's a point where they slow down and they stop, and that stop is when the velocity is 0. And it's a really important point for solving a lot of problems. So here we go. U is equal to 12 meters per second to the minus 1. S is equal to 36 meters, so this distance is 36 meters. And at this point, they come to rest, so they stop at that point. So we've got 3 bits of information. We've got U, we've got V, and we've got S. And that plays nicely into our hands, okay, because if we use v squared equals u squared plus 2as, the only thing that we haven't got, we've got the velocity, the initial velocity, the distance. The only thing that we haven't got is a. Okay, so that's what we're going to do. Velocity squared 0, 0 squared is 0, 12 squared is 144, plus 2 times a times the distance, which is 36. And wow, the numbers are nice, aren't they here? So 2 times 36 is 72. So 0 is equal to 144 plus 72a. If we take the 144 over to the other side, it gives us minus 144 is equal to 72a. Divide both sides by 72, and a, you can see, is minus 2. Okay, so what is that telling you? Well, first of all, it's telling you the answer, and the answer is that the minus is the deceleration. So it has a deceleration of 2 meters per second to the minus 2. Okay, so don't write it down as minus 2. I suppose the acceleration is minus 2. The deceleration, with the word using deceleration, is 2 meters per second. Deceleration means it's slowing down. I suppose it's like a double negative. If you say it has a deceleration of minus 2, you're saying it's like minus is slowing down by minus 2. Anyway, don't use double negatives. Apparently in English they're a real no-no. Thought I'd get that joke in. Okay, so next one, a particle moves with so number 6 here that I'm going to go through. A particle moves with acceleration of 3 meters per second, speeding up, and does 38 meters in 4 seconds. Find U and V. Okay, so here it is. Let's draw the diagram. It goes from there to there. And it has an acceleration of 3 meters per second. So that's squared. That's that. 38 meters. And t equals 4. T equals 0 there. We don't know u and we don't know v. And t is equal to 4. So for this one, we don't want to use v squared equals u squared, that one, because there's 2 unknowns in there. So we're going to use, if we use s equals ut plus a half a t squared, we've got the time, we've got the acceleration, we've got the distance, so the only thing that we haven't got is u, so we can work out the initial velocity. And once we've got the initial velocity, we can work out the we can then work out, which one am I doing here, number 6? We can then work out the velocity. Okay, so yeah, I just done that one wrong. What I'm doing there. So yeah, so 38, let's just, 38 is equal to the initial velocity times the time, so 4t, hang on a minute, 4u, whoops, t is 4, plus a half times 3 times 4 squared, which is 16. I'm going to go straight for that. 16, so that's going to be 24. So 38 is equal to 4u plus 24. Take 24 off both sides. It's going to be 14 is equal to 4u, and divide both sides by 4, 7, 3.5. Okay, so u is equal to 3.5 meters per second. So 3.5. And then I'm going to go, I'm going to squeeze it on here. I'm actually going to go, I want to find v, I'm going to go v equals u plus at. Squeeze that one on, and the velocity we don't know, and it's going to be the initial velocity 3.5 plus the acceleration, which is 3 times the time, which is 4. So 3 times 4 is 12. 12 plus 3.5 is 15.5 meters per second. There we go. That's that one. I'm just checking my screen to make sure that's squeezed on for you. Yeah, just about. Number 9, a bit more this one actually. A particle moving from O to A, acceleration is 2.5, t isn't it? Okay, so let's draw a diagram. Here we go. So O and A, t is 0. At this end here, u is equal to 8 meters per second. The acceleration is 2.5 meters per second squared. Constant. These are all constant acceleration, by the way. That is 40 meters there, and we've got to find the time there that it takes to reach A, and we want the velocity at A as well. Okay, so let's start with finding the time. So I'm going to have to use s equals ut plus a half at squared for that. And you can try using it. If you're saying, well, how come you've gone straight to that? Well, try using one of the others and you haven't got enough information. So it's as simple as that. Actually, for this one, you could use v equals u plus at to find the velocity at A, couldn't you? V equals u plus at. Yeah, and then you could do it the other way around actually, and then once you've got the velocity, you can then find the time. Oh no, you haven't got the time either. Forget that. Ignore that. We're going with this one anyway. S equals ut plus a half at squared. So the distance is 40. Okay, so 40 meters. Ut. So we're going 8t plus a half times 2.5 times t squared. So now we've got 40 is equal to 8t plus 1.25 t squared. Okay, so now what I'm going to do is I'm going to move the 40 over to this side. So I've got 0 is equal to 1.25 t squared plus 8t minus 40. Now that there, I don't like that, so I'm going to times both sides by 4, and that will give me 0 on that side. If I times this by 4, it's going to give me 5t squared plus 4 8s are 32 t minus 160. Okay, so it gives me that. I'm not even going to try and factorise that. It may factorise, but I'm going to go use the formula now. So this is minus b, so minus 32. Now I can go plus or minus the square root, but if I go minus, remember I'm finding a time, and if I go minus, it's going to give me a negative time, and there's no such thing as a negative time in this situation. So I only want the positive value of it, so I'm going to go plus the square root of b squared, 32 squared, minus 4 times 5 times minus 160. And you can see we've got two minuses there, so it's plus all over 2a, which is 10. Okay, so you typed all of that into your calculator. Okay, so that gives me 3.3. Okay, so that gives me a time of 3.3 seconds. I'm just checking that's on my screen. Okay, and it is. So that's my time. If I wanted to work out the velocity, I don't want to really use that because I've rounded it off. So 3.3 seconds is my time. I would have got, if I put a minus, I would have got a negative time. I don't want that one. So it's taken 3.3 seconds to travel 40 meters. So if I use v squared equals u squared plus 2as to find the velocity at this point here. Now I'm not finding the velocity using the time, I'm finding the velocity using the distance it's travelled. So if I use that, I'm going v squared equals u squared, which is going to be 64, plus 2 times 2.5 times 40. So v squared is equal to 5 4 is 200, so all together 264. And so I'm square rooting that, and I only want the positive velocity. So square root of 264 equals 16.2. We'll do meters per second minus 1. And that's number 9. Okay, so pretty crowded, but that's the first 3 questions for you, 3, 6 and 9. So do those first with me and then fill in the gaps. I'm going to do number 12 with you now, so put those out. Number 12. So here we go. So number 12 is, I don't like that, it's going a bit sharp, but now it's, so number 12 is a particle P. So this is one where a particle P moving along the x-axis with constant deceleration of 4 meters per second. Okay, so it's going along the x-axis with constant deceleration of 4 meters per second. So that's its acceleration is minus 4 meters per second. And at time t equals 0, P passes through the origin. So the origin, there's the origin, and the u is 14 meters per second to minus 1. And it's travelling in the positive direction. The point A lies on the line such that A is 22.5 meters. Okay. And it says find A, the difference. All right, the difference in times when it passes A. Okay, so it says that, and the total distance travelled. Between these times. Okay, so that's the question. So this is one, like in the lesson that I did for you, 3b, is that it's slowing down, it goes past A, it stops, and then it turns and comes back. So it keeps going, the acceleration keeps going down, but when we get down to 0, it goes then a velocity of minus 4 after another second, and that is, in other words, it's speeding up but coming in the other direction. Okay, so let's have a look at this. So let's do part A. So we want to find the difference in the times when it passes A. So it passes A when S is 22.5. So if we go S equals ut plus a half a t squared. Now this is, we've got everything else. We've got u, we've got S, we've got the acceleration. So this formula is going to give us the 2 times when it's slowing down past there and speeding up, coming back the other way. It's going to reach somewhere down here, isn't it? And then it's going to turn and go back down as it slows down. So we've got 22.5 is equal to ut 14t plus a half times minus 4 times t squared. So 22.5 is equal to 14t minus 2t squared. Okay, so we get that. If we take everything over to one side, we've then got 2t squared minus 14t plus 22.5 is equal to 0. I'm going to actually sort of double that, because I'm going to attempt to factorise it if it does. So I get 4t squared minus 28t plus, and that is 45, is equal to 0. So I've got that. Is it going to factorise? You can just stick it straight into the formula, so you don't have to do all the thinking that I'm doing now. 2 9s are 18, and 2 10, yeah, it's actually going to factorise 2t. I've just spotted that. So 9 and 5, we'll put those in, and a minus, and that works actually. But just stick them straight into the formula. So for this here, you can see that t is equal to 5 over 2 and t is equal to 9 over 2. They're both positive. So t is equal to 2.5, and the time here is equal to 4.5. So it takes 2.5 seconds to reach A. It carries on slowing down, and then after 4.5 seconds, it's back like Halley's Comet, okay, on its return journey, you know, around the sun. And there we go. So the difference between the 2 times is 2 seconds. Okay, between 2.5 and 4.5. Okay, so here it reaches this point at 2.5 and also at 4.5. Now it's saying the total distance travelled, okay? So this is, it slows down, it stops at this point and then comes back. So we want to work out that distance until it stops. So what I'm going to do here is I'm going to say what happens at this point. Well, at this point the velocity is 0, isn't it? That's a really important point. So when it stops, and it stops instantaneously and then comes back the other way, and at that point the velocity is 0. So we're looking at how far has it travelled when v is 0. Okay, so if we use v squared equals u squared plus 2as, we're saying the velocity is 0 when the initial velocity was 14, so 14 squared, plus 2 times minus 4 times s, we don't know. So we're trying to find that distance, aren't we? So we've got 0 is equal to 14 squared, which is 196, minus 8s. So 8s is equal to 196, add in 8s to both sides, divide by 8, and 196 divided by 8, 196 divided by 8 is 49 over 2, which is 24.5. So that here, S is 24.5 metres. So to answer this question, the total distance travelled in between these times. So in other words, from A to when it stops and then back to A again, but that's between those times. Well, to A it's 22.5, so it's another 2 metres to it stops and then another 2 metres back. So it's 4 metres altogether. Okay, so it goes a further 2 metres to stop and then back another 2 metres before it reaches point A again. So that one's 4 metres. Okay, and that's question 12. Alright, and then the last one I'm going to go through with you is a cracker, number 14. Okay, I hate these ones. And you think I'm bad at stalling at those, but number 14, yeah, number 14 is good fun. Okay, so number 14, so 2 particles P and Q. And it says the 2 particles are moving along the same straight horizontal line with constant accelerations of 2 meters per second So 2 meters per second squared, and the acceleration of q is 3.6 meters per second squared. And it says that at t is equal to 0, okay, I'm just reading this, sorry. At p passes through point A, so this is point A here. At t is 0, it has an initial velocity. P passes through the point A with a speed of 4 meters per second. Okay, 1 second later, q travels through A with 3, so u is equal to 3 meters per second, but it's accelerating, and that's a second later start. And it says, write down an expression for the displacements of p and q. Okay, so write down an expression. So it wants for p and for q, it wants an s, an expression for the displacement. Displacement is s. In terms of t, okay, so comparing it to p, in terms of t, where t is in the seconds in the time after p has passed a. Okay, so here we go. No problem with this one. Let's have a look at it. So it's saying that, let's get my colour, let's do this in orange. Okay, so an equation for the displacement of p. So s equals ut plus a half a t squared. So the displacement is going to be 4t, because u is 4, the initial velocity, plus a half times the acceleration is 2 times t squared. So s is equal to 4t plus t squared. Half of 2 is 2. Okay. Now then, this is the confusing bit. We want this in terms of t as well, but it starts a second later. Okay. So you've got to think, we're going to do s is equal to ut. So ut, I've not put the value of t in yet, plus a half times the acceleration of this one is 3.6 times t squared, and t squared in here. So this is the expression for this one, but it's got to be in terms of t compared to this. Well, think about where this one is, q, after 1 second. After 1 second, this is the way that I think about it. After 1 second, s is 0. Okay, because it's not moved after 1 second. It's not moved anywhere, because it only passes this point 1 second after this has already started. So after 1 second, this is a delay of a second. The only way that we can make that 0 is to have t minus 1 in here, because after 1 second, if t was 1, it makes s, 0, because this would all be 0, wouldn't it? Okay, so this is a 1 second delay, and by putting t minus 1 into this equation here for it, it tells us where this is in comparison with the time, because the clock started running the moment that this one took off. Okay, so that's the confusing bit about this one. That's the expression for this one. So we've got, if we multiply that out, we get 3t minus 3 plus 1.8, and t minus 1 squared is t squared minus 2t plus 1. Okay, multiplying that out. So those are our two expressions. It tells us, both of these expressions tells us where both of those are after time t. Time t being the point where our simulation runs. And our simulation runs from when particle P starts. Okay. So we want to find, what are we trying to find with this then? It says for 14, find the value of t where these particles meet. Well, they meet, they've travelled the same distance, so what we're doing is we'll put it simultaneous equations. we're putting these s's the same. So we're saying when 4t plus t squared equals 3t minus 3 plus, and I'm going to multiply all that out now. There it is. Okay. Now what I'm going to do is I'm going to take everything over to one side and simplify. So I've got a naught on this side. So if I take off t squared from both sides, I get 0.8 t squared. And if I've got 3t, if I take where I've got a 3t, take away 3.6t on this side, so that's minus 0.6. So I'm going to have minus 4.6t. Okay, and I've got minus 3 plus 1.8. So 1.8 minus 3 is going to be minus 1.2. Okay, so I've got that rather ugly, simplified. I'm going to times everything by 10 to get rid of those decimals. So we get 0 is equal to 8t squared minus 46t minus 12. And I'm going to divide by 2 because they're all even numbers. Can I divide? No, I can't divide by 4. So divide by 2 and I get 4t squared minus 23t minus 6. Now you can, if you want, just use the formula because it's unlikely that it's going to factorise, but this one does factorise, and it factorises to 1 and 6. That does it nicely because I can see here that 4 6s are 24 and the 1 makes you 23. So I'm going to go, we want a minus there and a plus. So t is equal to minus a quarter, okay, and t is equal to 6. That doesn't exist. We don't have a time of minus a quarter. So after 6 seconds, that means after this has been travelling 6 seconds, this one of course has only been travelling 5 seconds. They have passed each other, okay? But that's after 6 seconds, after p starts accelerating off from 4 meters per second. Okay, so after 6 seconds, and then of course you want to find where they meet. That's part B. So you can just stick it into any of the formulas, and if you just stick it into this formula, t into this formula, so s is equal to 6 fours are 24 plus 36. That is in 60 meters. There we go. Okay, you could have put it into this one, but you still would have got 60 meters. But that one was easy because we'd already simplified that to that, and then it was easy just to put t6 in. Okay, so they meet after 6 seconds, after this one sort of started, and 60 meters down the road from A. Okay, and that's a bit of a long-winded one. I waffled a little bit, so sorry about that. But you're not sitting there watching all of this. You're doing the questions, aren't you? And I would have a go at those ones first. Okay.